So as you said, this is a paper on test optional admissions with Wouter, Dessein, and Navin Kartik, both at Columbia. So just to give a little bit of background about US college admissions, when you're applying to college in the US, you submit your high school transcript with all your grades, you write an essay, you talk about your extracurriculars, and you also historically have submitted a standardized test score. Either the ACT or the SAT are the two national standardized tests. But there's been a recent movement away from requiring standardized testing. So even before the pandemic, a lot of smaller liberal arts colleges stopped requiring standardized tests on the grounds that standardized tests often seem to favor people from higher socioeconomic backgrounds, people of certain races, white and Asians get higher standardized test scores on average than Blacks and Hispanics. So for purposes of access and equity, there's a move to de-emphasize standardized testing by making them optional rather than required. And so here's a news article from 2018 about how the University of Chicago was the first kind of top research university in the US to join this test optional movement. So it was picking up steam before the pandemic. Once the pandemic hit, for obvious reasons, almost every school went test optional, or in fact test blind, just because it was all of a sudden physically difficult for people to actually take these tests. And for the moment, we're kind of in this limbo state where most top schools are still test optional, but they're kind of still doing it as a temporary measure, no plans yet to go back, no plans to stay, just kind of waiting and seeing at the moment. One interesting case study is the University of California's public system, where back in 1996, the voters passed an initiative to ban the use of race in admissions. And the University of California system, obviously the people there are very interested in affirmative action and increasing diversity, which now the voters have told them they're not allowed to do in the standard way. So they're very concerned about the disparate impact of requiring these standardized tests. In 2018, they set up a faculty task force to study the use of standardized tests. Before they made any final decision, the pandemic hit in 2020, and they very quickly moved to test optional. And in fact, soon afterwards, they switched to officially being permanently test blind. So now they will not look at a standardized test score, even if you submit it. They just commit to not even looking at that. Now, the reason that I find this case study interesting is because right before the pandemic hit, the faculty task force announced its recommendations, which was to keep the tests, not to get rid of them. They looked at data from the University of California system, and they found that standardized test scores were actually very highly predictive of student success in college, more predictive than undergraduate GPA on its own, remained very predictive even after you added GPA to the mix. And it was predictive not just for some demographic groups, but for across all demographic groups. In fact, they found it to be a better predictor of success for underrepresented minority students, first generation, low-income families, and so forth. So if you're trying to figure out which of the minority or low-income people to admit, standardized test seems like it's your best bet. And so that's sort of the history of where our paper starts. We kind of look at this history and we found it a bit confusing. So first, just being economists, we asked ourselves, even if you're interested in diversity and equity, whatever your objective is, how can it possibly be that you can make better decisions with worse information? Even if standardized tests are, biased in favor of privileged students who, can do more test prep and get higher test scores, that's not really an argument for getting rid of standardized tests. That could be an argument for putting less weight on them or maybe adjusting for demographics when you consider how to use them. But again, very simple point that more information should only help you make better decisions. So why would you ever kind of want to hide this information? And so the first result in this paper that I'll present is a very simple impossibility result that formalizes this intuition and shows in a certain class of models that you cannot do better from going test optional or test blind than test mandatory. Again, just kind of trying to formalize the simple intuition that more information should be better. That's obviously not the ending point of this paper. That would be a very short paper. That's the starting point. Once we have this formal model with the impossibility result, we can ask what assumptions do we need to break in order to make it possible that going test optional can in fact help a college. And our story is going to be that the college faces social pressure. So there's some third party evaluating the college's admissions decisions. We call this third party society. It might be the parents of the students, the alumni of the college, the media, the government. Some aspect of society is going to judge the college on how it admits students. But specifically, it's going to judge the college based on how it admits the students, given the information that the college had available to it. And so the college can potentially reduce these disagreement costs, reduce this social pressure by adjusting the information that it looks at. In particular, by not observing test scores, we might reduce the social pressure. So I'll go into an example that illustrates how that can happen. And that presents us now with a trade-off. Not observing test scores can lower these disagreement costs. It can lower social pressure from society, but not observing information also, of course, means that we have worse information for making decisions about which students to admit. And so that's going to be the trade-off that we explore in the main model of the paper, where we can ask, what does a test optional equilibrium look like? So how does the college actually make admissions decisions between students who do submit versus don't submit test scores? Which students are going to submit test scores? How do admission outcomes differ from test mandatory? So for instance, which kinds of students will benefit from a switch to test optional? Which kind of students will be harmed? And then throughout the talk, we'll have something to say about when is it the case that a college prefers to go test optional versus being test mandatory? I'm not super optimistic that I'll have time to talk about it at the end, but in the paper, we go into an extended example illustrating the idea that a ban on affirmative action, so a ban on using something like race in admissions, can lead a college to want to switch from being test mandatory to being test blind. And so that's one interpretation of the story of what happened in the University of California system. And there are Supreme Court cases going on now where people are widely expecting the Supreme Court of the US to limit the use of race in admissions. And a lot of commentators have conjectured that if this does in fact lead to a ban on affirmative action, that a lot of colleges that are currently temporary test optional or test blind will make it permanent. And so we're able to kind of make that prediction in our model. All right, so let me go into the first part of the paper, what we call the puzzle, which is just formalizing the simple impossibility result, showing that in this class of models, a college cannot benefit from going test optional. And then we will talk about how to break this result. So suppose that there's a college that chooses whether to admit a student, and the student has some underlying ability. They have a horizontal or holistic fit at the college, call that H. They have some non-test observables, X, and they have a privately observed type Z. The non-test observables are observable to everyone, no matter what. Only the student observes their private type. Only the college observes the holistic fit. And then nobody observes the ability, but it's something the college cares about. It just can't observe it directly. So students want to get accepted to college. The timing of the game is as follows. First, the college chooses whether to be test mandatory or test optional. Then the college chooses some admission rule that maps the information it's going to receive into whether a student will be admitted or rejected. Then the student chooses test prep effort at a cost that can depend on both their public and their private type. The test score is realized, where the test score distribution depends on their underlying ability, the test prep effort, the public type, and the private type. And we interpret this test score as being a signal, a noisy signal of the underlying ability that nobody can observe directly. Think of this as how well you'll perform in college. Then after taking the test, the student decides whether or not to apply to the college at some cost that can depend on the private and the public type. If the student applies in a test mandatory world, the student must submit their test score. In a test optional world, the student can look at their test score and decide whether to submit. The student can also add a cheap talk message to their college application. And then the college makes an admission decision based on the observables, X that it sees, the horizontal fit that it observes privately, the cheap talk message, and then, if submitted, the test score. Here is the result. The college can never strictly benefit from going test optional. And the intuition, as I said, it's just extremely simple. It's that hiding information can never help you make better decisions, as long as you have flexibility over how to use this information. So formally, we prove that any test optional equilibrium can just be replicated in a test mandatory environment where we say, everyone, submit your test score. And if you wouldn't have submitted it in a test optional world, then we'll just ignore it and we'll evaluate you as if we were test optional. Now, the college can presumably do even better than this by using this informative test scores in some way, but the college can never do worse by seeing test scores than by not seeing them. So that's the simple impossibility result that says in this class of models, you can never benefit by going test optional. So how do we break this result? One way of breaking this result would be having a direct cost of sitting for the test or submitting the test score to the college. Notice that in this model, I said that students have a cost of preparing for the test, so studying for the test, but not a direct cost of just sitting and taking the test. And you can see why a cost of sitting for the test could break this result. Students with a very high cost now simply cannot apply to a test mandatory college without incurring this cost. They can apply to a test optional college without incurring this cost. So there's a recent computer science paper that kind of looks at this sort of story and looks at some trade-offs for a college going test optional there. Our view is that we don't really think of this story as being very relevant outside of the pandemic. So during the pandemic, absolutely, it's just, you might not be willing to sit in a testing center with 500 other students in the room. After the pandemic has, now more or less receded, we don't view the cost of sitting for the test as that relevant, even if the cost of studying for the test might be very, very high. So as an example, the SAT test takes about 3 hours, so half a day of school. It costs $60, but there are fee waivers for low-income students. And in fact, any student who is in the who receives a free or subsidized lunch, who's sort of already known to the school to be low income, they automatically get a fee waiver without needing to apply for it or ask anyone for this. as an illustration of the fact that we don't think it's cost prohibitive just to sit down and take the test. In fact, prior to the pandemic, about half of US states actually required students to take one of these standardized tests for high school graduation. So it just seems like it's not that much of a barrier to actually take the test, even if studying for the test might be very, very costly. Another thing that could break this result is what we think of as just non-equilibrium behavior or behavioral factors. So we saw tweets, however representative these may be, of people saying, I would never apply to a test mandatory college because, it offends me. I find it, because of my commitment to diversity and equity, I refuse to apply to a test mandatory college. And so if students have that sort of behavior where they just like applying to test optional colleges, even if they're going to submit their test score anyway, and they dislike applying to test mandatory colleges, that could be one reason why colleges might benefit from going test optional to increase their applications. There's other kind of stories in that line where people just don't act in kind of the equilibrium that we would have predicted. There's just costs or behaviors outside of the model that could break it. Another way of breaking this model or breaking this result is that there's some kind of external constraints on the college's decision-making. So an extreme version of the story would be the government has passed a law that says if students submit a test score, we have to evaluate them according to this rule. If they don't submit a test score, you can evaluate them according to that rule. And so if we are just forced to put too much weight on tests, much more weight than we want to, if tests are submitted, that could be another good reason not to require test scores. Now, those laws don't actually exist, so we don't find that to be super compelling, but we're going to explore kind of a milder version of that, where nobody is forcing the college to make certain decisions, but someone is judging the college based on the decisions that it makes. And so the college faces social pressure on how it's deciding to admit students. And so if there's no questions, I'll just jump into an example illustrating the social pressure story that I'll then build into the full model. Okay. So suppose that we have students who have some given observables and they differ on their test scores, which are, let's say, uniform on 0 to 100. And let's say these students have observables such that the college just wants to accept all of them regardless of their test score. Even if they get a really bad test score, we want to accept these students. So there's a recent newspaper article about how Ivy League colleges value students who fence in admissions. So call these students fencing champions. The college wants to admit them no matter what their test score is, but society disagrees. Society doesn't care whether you're good at fencing or not. So society says these students should be admitted if their test score is above 40, but they should be rejected if their test score is below 40. So society's utility is T minus 40 for accepting these students, where we normalize the utility of rejection to be 0. And society is going to judge the college if the college's decision for a student disagrees with society's preference, given the available information. So specifically, look at how much disagreement there is. We call this D, between the college and society. If we accept a student who has a test score above 40, then there's no disagreement. If we reject a student who submits a test score below 40, there's no disagreement. But if we accept a student who submits a test score below 40, then the college has to pay a disagreement cost equal to how far society's utility is from 0. So 40 minus T. Or if we reject a student who submits a test score above 40, we have to pay a disagreement cost equal to how much society wants to accept this student. So in graphical terms, the blue line here is the disagreement cost the college faces for accepting a student, no disagreement cost when society's utility is below zero. Sorry, for accepting a student, the disagreement cost is equal to minus society's utility when society wants you to reject the student, not accept them. And then there's no disagreement cost for accepting a student when society agrees the student should be accepted. For rejecting a student, no disagreement cost of rejecting a student with test score below 40, but a disagreement cost of accepting a student with a test score above 40 that's linearly increasing in the test score. So let's just work out. So the college wants to accept all these students. If we ask the students to submit test scores, and then we accept all of them, our disagreement cost is going to be the area under the red curve. So just the integral of this red curve, which works out to 8. The area under the blue curve, that's the cost of accepting the students. So if we want to accept them all and they submit, we have the area under the blue curve and it works out to 8. If we accept all of the students, but we ask them not to submit scores, though, now we can admit them all at 0 disagreement cost. Because given the available information that the college has, the average test score is 50. So if no student is submitting a test score, society says, well, in expectation, I think your test score is 50. My utility for admitting a student with a test score of 50 is 10. It's above 0. So society can't point to a single student you've admitted that you should have rejected. Society just says, yeah, every student I also think should be accepted given the information I have. So by hiding information, we can now accept all of these students at no disagreement cost instead of a positive disagreement cost. Now, what if we flip things around and society wants to reject all of these students rather than accept all of them? So I grew up in the state of New Jersey. Suppose that the college says, we don't like applicants from New Jersey. We want to reject all of them no matter what their test score is. But society still says, no, I think you should accept them if their test score is above 40. So if all of the students submit test scores, then now we face a disagreement cost equal to the area under the red curve. It works out to a disagreement cost of 18 if we reject everyone after they all submit test scores. Now, if the students don't submit test scores, we can't get away from disagreement cost entirely by hiding test scores and then rejecting them, because society wants to accept, not reject, the average student, but we can still reduce disagreement costs. Remember, society says, well, if you don't submit a test score, your average test score is 50, so my payoff for accepting you is 10. If you're rejected, then the college is going to face a cost of 10 for rejecting these students, which is less than 18. So we see that whether the college wants to accept all of these students or whether the college wants to reject all of these students, regardless, it reduces disagreement costs by hiding information. And so if we want to understand what's going on here, there's a very simple intuition here that should be familiar if you kind of are in the Bayesian persuasion or information design literature, which is when you look at these blue and red curves, the disagreement costs, whether you're accepting students or whether you're rejecting them, the disagreement cost function is convex in the test score. See a question, I'll get to it in 1 second. Anytime we see a convex function, we know that we can reduce its expectation, or that the the function evaluated at the expectation is less than the expectation of the function. This is just Jensen's inequality. So whether we're on the blue curve or we're on the red curve, we reduce costs and expectation by pooling all the students, hiding information, and then evaluating the cost at that average rather than taking the average of the cost. Yeah, question from Chen Hao?
So you assume that the society's decision rule or the way it comes up with the utilities by looking at expectation. I wonder if the result will be robust if the society is not expected utility maximizer. Maybe it's ambiguous, like ambiguity averse. Okay, why I'm asking these questions? In general, it seems, the society looks more careful. They were more attracted by these blockbuster news, which are more extreme case than the average situation. When something made to the news, it might be a very extreme case, but it's caused a lot of social pressure. On average, what's going on average, actually, people might not that aware of it.
Yeah. So going back to the cost function here, I think of it as just for simplicity, we gave society a linear affine utility as a function of the test score. I think we can capture your story even without going, moving away from expected utility maximizing, just by giving society, a nonlinear preference, a sort of payoff that's nonlinear in the test score and kind of jumps at these extremes. In that case, the same logic would hold. We just wouldn't, rather than saying plug in the expected test score, we would plug in the expected utility given the distribution of test scores. Now, another answer to your question is we think of ourselves as sort of tying our hands by forcing society to be Bayesian. And clearly, if we allow society to be non-Bayesian, in some class of models, this will still go through. But there might also be new effects on, how the college can kind of trick society or take advantage of the non-Bayesian updating in order to maybe do even better. And that, of course, is going to depend on the specific details of how you model this ambiguity aversion or non-expected utility behavior. So we think of ourselves as without saying society necessarily is Bayesian, we're sort of tying our hands to say, suppose they're Bayesian and it makes this story very clean. And we think this story could be embedded in a non-Bayesian world as well. And then we make, once we're doing Bayesian, make things linear just for simplicity. So then we can talk about expected test score rather than expected utility given the distribution of test scores. All right. So that's the basic story of how hiding information can reduce disagreement costs, given the decision that you're making. Of course, there's a trade-off here because the college doesn't necessarily want to accept everyone or reject everyone regardless of their test score. We think of the test score as providing useful information for the college in what decision to make. And so there's an important trade-off that we now want to model in depth, where not seeing test scores can reduce disagreement costs, but it also means you have worse information with which to make decisions. So let's now embed this trade-off in kind of a full model of test optional admissions. So going into the model, we have a student applying to a college, and we're now going to abstract away from any sort of application cost. We just say there's a student who is sending an application to this college. The student has some observables that are drawn from a distribution fx. And then the student is also endowed with a test score that's drawn from some distribution that might depend on the observables x. So again, abstracting away from the cost of studying or taking the test, and just saying students are endowed with the test score that we're going to focus on here. The college is going to decide whether to accept or reject a student, where the college's utility is going to be some function of observables plus some function of observables times the test score. So this V for value, W for weight. And really, to keep things simple, it's not important for us, it just keeps the notation down. We're going to assume that the college has affine utility in the test score, again, just so that we can make things simple for ourselves by plugging in the expected test score rather than the expected utility given the distribution of test scores when there's uncertainty. So the college has this utility for accepting a student with the rejection utility normalized to 0. And likewise, society has the same form of utility, some function of observables plus some weight as a function of observables times the test score, with the rejection normalized to 0. The college is a strategic player. Society is not a strategic player. Why does society's preferences matter? Society's preferences matter because the college faces social pressure from society. Specifically, we're going to assume that society is Bayesian in evaluating missing test scores. So if we observe a test score, society knows your test score is the thing you submitted. If you don't submit a test score, then society is going to be Bayesian and will, calculate your expected test score given the information we have. And then the disagreement level is going to be the same thing from the example. It's if you reject a student that society thinks should be rejected, or if you accept a student society thinks should be accepted, you pay no disagreement cost. If you accept a student society thinks should be rejected, what is society's net utility for rejecting that student? That's the level of disagreement you face. Or if you accept a student, forget which one I just said. If you accept a student that society thinks should be rejected or reject one that society thinks should be accepted, we look at the magnitude of the disagreement. How much does society think you're making a mistake? That's the disagreement level. And then the college's full payoff is, I keep losing that. The college's full payoff is the underlying utility, the UC of xt, the little u, minus some scaling of this disagreement level. So parameter delta times the disagreement level d. So the college cares about the underlying utility of the people it's admitting, plus it doesn't like disagreement costs with society. There's no asymmetric information between the college and society in this model. So if the college doesn't observe test scores, then society doesn't either. The observables are always observed by everyone. The test score is observed under a test mandatory regime. In a test optional regime, the student chooses whether to submit, and I'll get into the student's choice momentarily. The college admission policy is now going to consist of two parts. There's an imputation rule and an acceptance rule. The imputation rule is relevant in the test optional world. It says, if a student doesn't submit a test score, how do we evaluate this student? And our answer is, we impute a test score for them as a function of their observables, and we commit to treating non-submitters as if their test score were equal to the imputed level, where we allow the imputation to be minus infinity or plus infinity as well, just to keep things simple for ourselves so we can talk about, imputing the highest possible score, imputing the lowest possible score without worrying about what the bounds actually are. And then we have an acceptance rule that maps observables and test scores to a probability of admitting the student, where this test score might be the submitted test score, or if a student hasn't submitted it and we've imputed a test score, then we plug in the imputed test score into this acceptance rule. We're going to impose that the acceptance rule be monotonic in the test score. So it's going to clean things up a little bit. It actually doesn't change any of the results, but it seems like a reasonable assumption, and it makes things a little bit easier to talk about. So suppose that we are restricted to acceptance rules that are weakly increasing in the submitted test score. All right. So the college always gets to choose the acceptance rule flexibly. We're going to consider two possibilities for the imputation rule. It might be flexibly chosen by the college, or the college might have restricted imputation, where the college is just given an exogenous imputation rule and doesn't get to choose it. So what's our thinking here? When you look at the public statements that colleges have put out about how they treat students who don't submit test scores when they're test optional, they say different kinds of things. So here's the language from Brown University's webpage. If you're not happy with your standardized test score, the choice of whether to submit that score is completely yours. Your application will be complete and will be contextually evaluated whether or not you submit scores. So that language isn't making any promises at all. All it's saying is we will evaluate you in context. So that's what we're thinking of for the flexible imputation. No promises. We will take the information we get and we will use it somehow. Other colleges put out statements that sound a little bit more like promises. USC, for instance, uses language that's very common. Applicants will not be penalized or put at a disadvantage if they choose not to submit standardized test scores. Dartmouth says, our admission committee will review each candidacy without second guessing the omission or presence of a testing element. So of course, none of these schools are like saying what an economist wants to know of like, how do you evaluate missing test scores? But it sort of sounds like they're making promises about some kind of fair treatment, kind of tying their hands in some way. So our favorite interpretation of this sort of language for tying their hands is that the colleges are promising what we call a no adverse inference imputation rule, which is that they're imputing the expected test score given your observables, but not given your decision not to submit. So it's just treating it as if this decision is non-strategic without second guessing the omission of a testing element. To us, that sounds a bit like saying, we're kind of not going to do the Bayesian updating on the fact that you actually made the strategic decision. So that could be one kind of exogenous imputation rule. Now, you might also, make this a little more subtle. Maybe you can imagine that the college says, we are going to adjust your the imputed test score for some factors like your grades. We commit not to adjusting the imputed test score for some other factors like race or demographics or what neighborhood you live in that might in fact be correlated with your test score, but we don't want to take those into account in our admissions decision. So you could imagine other rules like that. And we aren't really going to have results that are tied to a specific imputation rule, but this is the example of what we have in our head for some kind of restricted imputation rules. And so we'll look at what does the college do when it has flexible imputation, and what does the college do when it has restricted imputation, like one of these rules. So how do students decide whether to submit their test score in the test optional world? We make a very simple assumption, which is that the student chooses to submit if their test score is above the imputed level, and they don't submit if their test score is below the imputed level. And remember, because we've restricted the acceptance rule to be increasing in your test score, this strategy guarantees that you maximize your acceptance probability. No, even if you don't know what the college's acceptance rule is, this is the safe one that says, whatever their acceptance rule is, this policy gives you the highest possible test score that's going to be plugged into the plug into the admission rule. Now, there's a really big assumption we're making here, which is that the students know the imputed test score, and therefore they know whether they should submit or not. And we fully grant in the world right now, nobody has any clue how colleges are making these decisions. So there's no sense in which students, know that if I don't submit a test score, it'll be as if my test score is 87 or 53 or whatever. So we're making this fairly strong equilibrium assumption for a world where we're clearly not yet in equilibrium. So think of it not necessarily as a prediction of behavior today, but a long-run prediction of behavior. The extreme version of this would be, imagine a college application that has the last line of the application being, please submit your test score, or please enter it here. If you don't enter a test score, the following score will be imputed for you, 751. So now it's very easy to know, well, if my test score is below 751, I should not enter it. I'll just take the 751. If my test score is above 751, I should enter it. So I'll get a better test score. So that's kind of the world we are modeling, like an as if students really fully understand what's going on. And of course, that's not quite right, but we're kind of comfortable with that equilibrium assumption. Okay, so wrapping up the model, recall that the college maximizes its underlying utility minus delta times the disagreement level. Fixing the information that the college has at the time it's making the accept or reject decision, so fixing the imputation rule, maximizing this objective is equivalent to maximizing what we call the ex post utility, which is just the weighted average of the college's utility and society's utility, where society gets a weight equal to delta, the strength of social pressure parameter. So when the college is making decisions that affect which test scores are submitted or not, it's not as if it's maximizing this ex post utility, but given the information it has at the time it's making the accept or reject decision, it's as if it's maximizing this weighted average of the college and society's utility. So here's kind of the picture I have in my head of what's going on in this model. Imagine a simple example where the college and society both have linear utilities where there's just a one-dimensional observable, just better observables and worse observables. And the college and society both value this observable and they value test scores, but they put different weight on the test scores. The left graph shows indifference curves over observables and test scores when the college puts less weight on the tests. And so now the college's indifference curve is going to be steeper than society's, meaning that at low observables, the college is more selective than the society, meaning it has a higher test score bar for admission. At high observables, the college is less selective. It is a lower test score bar for admission. If the college puts more weight on the test scores than society does, then this flips, and the college now has a flatter indifference curve, society has a steeper indifference curve, with the ex post indifference curve kind of in the middle regardless. The point of this example is that you shouldn't think of the disagreement between society and the college as society is generally more selective or less selective. It's all about which students. The college is going to be more selective on some students, less selective on other students. It might be the college is less selective on students with good observables. It might be the college is less selective on students with bad observables. But that's sort of the kind of the preference disagreement that we think of as going on in this model. All right. So now let's solve the model. We start with the test mandatory world. Test mandatory solution is very simple. When students must submit test scores, the college simply accepts a student if their ex post utility is above 0, and they reject the student if the ex post utility is below 0. So on these graphs, you accept them if they're above the green line, reject if they're below the green line. Now, in a test optional world, we have a somewhat related result, which is that fix any imputation function, so whether it's flexibly chosen or exogenously given, fix the imputation rule. Then on path, it's optimal for the college to accept submitters if and only if the ex post utility is positive. And it's optimal to accept non-submitters only if the expected ex post utility is positive. Now, this holds on path. The college does, in fact, need some commitment power off path. Specifically, imagine that the college is less selective than society, or sorry, the college is more selective than society. And so the college is, so you have society's bar for admission here, then the ex post bar, then the college's underlying bar. If the college ends up setting an imputation, or if there is an exogenous imputation that's above the ex post threshold, then the college might be rejecting all of the students who don't submit their test scores. And so some of these students have test scores above the ex post threshold, and they say, wait, why don't I just switch to submitting instead of not submitting? And it'll be ex post optimal for the college to accept me. The college has commitment power, and the college will say, I'm committing to rejecting you if you submit off path. So even if your test score is above the ex post threshold, but below the submission threshold, below the imputed level, then I'm going to reject you if you submit a test score when you shouldn't have, even when it would have been ex post optimal to accept you. And so that's the only commitment power that the college ends up employing in equilibrium. All right. So let's now solve the model when the college is test optional with flexible imputation. And it turns out that the answer to how the college sets the imputation level depends on whether the college has a lower bar than society or a higher bar. So whether the college is more selective or less selective at these observables. This is all observable by observable. If the college has a higher bar at some observables, meaning the college is more selective, then it turns out what's optimal is to set an imputation level somewhere between the ex post bar and the college's underlying bar. And then we reject all the applicants with test scores below the imputed level, including rejecting all the non-submitters. And then we accept applicants who submit a test score above the imputed level. Now, recall, under test mandatory, we reject all the students with test scores below the ex post level, and we accept if the test score is above the ex post level. Now we're setting a weakly higher imputation level and then rejecting everyone below that. So you can see that we're rejecting more students at observables where the college has a higher bar. So students are worse off in a kind of set inclusion sense. Some new students are getting rejected who were previously getting accepted. In picture terms, here's one numerical example where the college is more selective than society. So society wants you to accept applicants with test scores above 25. The college only wants to accept them with test scores above 55. So these would be applicants from New Jersey that the college doesn't like. And the best the college can do is to set an imputation level of 50, which is above the ex post level of 40. Now notice from this graph that even if the college replicated the test mandatory outcome by setting an imputation level of 40 and then rejecting all the non-submitters, it would still do better than test mandatory by lowering disagreement costs, because we're pooling together. Some people society wants to reject, some people society wants to accept. When you pool them together, you lower disagreement costs. But we can do even better than that by raising the imputation level and then continuing to reject more people. So instead of rejecting people below 40, we now get away with rejecting people below 50. And in fact, we're still paying no disagreement costs here. One possibility is that, in fact, the numbers are such that the college can get its first best by setting an imputation level at its underlying utility bar. So in this case, at a test score of 70, we reject everyone with the test score below 70 who doesn't submit. The average test score of people below 70 is 35, if test scores are uniform, which is below society's bar. And so we can reject everyone that we want to reject at no disagreement cost. So in this example, the college can in fact achieve its first best by going test optional. So that was the case where the college has a higher bar than society. Now, what if the college has a lower bar than society? So the college is now less selective. College wants to admit more students. In this case, one of two things might happen. Either the college sets a really high imputation level so that nobody submits their test score, and then we just accept everyone, or the college replicates the test mandatory outcome by setting an imputation level equal to the ex post bar or somewhere below that, and then rejecting all the non-submitters. So you see with these two cases that we are now accepting weekly more people. In the second case, we're accepting the same students as test mandatory, but in the first case, we're accepting more students. We're now accepting people with low test scores who would previously have been rejected. So at observables where the college has a lower bar, where the college wants to admit more students, students are going to be weekly better off. In picture terms, here's a numerical example where the best the college can do is to set a really high imputation level, nobody submits, and then we just accept everyone. And then here are numbers where the best the college can do is to set a low imputation level, and then we just replicate the test mandatory outcome. Now, one thing you see here is that when we have flexible imputation, going test optional always improves on test mandatory at any observable we have. We either replicate test mandatory or we do better. And you kind of see that this had to be the case because the college has the option of imputing a test score of minus infinity and then having everyone submit. And so in that case, going test optional would just literally replicate test mandatory. I say I'm test optional, but also I say, if you don't submit your test score, you'll never get accepted. Everyone should just submit their test score. So it's as if we're kind of test mandatory anyway. So we could always do at least as well as that. And in fact, we show that you can do better. So if the college is completely flexible, going test optional, in fact, cannot hurt it. So maybe the more interesting case then is when we face restricted imputation, where the college doesn't have all this flexibility. And now there's going to be a trade-off of it might help, it might hurt, just kind of depending on the numbers. So when you have restricted imputation, that's the case where the imputation rule is exogenous. The student submission behavior is going to be determined by the imputation rule. Submit if above imputed score, don't submit if below. And then the college is going to do ex post optimal acceptance given the submission behavior. So we saw these graphs before. Now, instead of choosing this level to impute test scores to, it could be here, it could be there, it could be anywhere, it could be replicating test mandatory payoffs, we could be doing better, we could be doing worse. It just depends on the numbers. So here is something we can say systematically about which students benefit or are harmed by going test optional. Informally, take some path of observables going from low to high. At low observables, student outcomes will be the same as test mandatory. These are observables where the imputed test score is below the ex post threshold, and so we just replicate the ex post optimal admissions. At medium observables, students are harmed by going test optional. These are going to be observables where the imputed score is above the ex post optimal threshold. So now we're pooling together more people than we were previously rejecting, but we're still rejecting them. And then at high observables, sorry, I didn't introduce this notation yet. L is just the expected test score of the non-submitters. At high observables, student benefit from going test optional. These are test scores where the observables are good enough that we just accept people who don't submit. And so at low observables, we replicate test mandatory outcomes. At medium observables, we start rejecting some new people. Then the observables get good enough that we start accepting non-submitters, and then we are students benefit. So we formalize this kind of low, medium, high observables by saying, imagine that we have a parametric path of observables parameterized by some Q, that's a real number, where the college and society both have payoffs that are some function of observables plus the test score. And then higher observables, so higher Q, corresponds to a bigger benefit from admission for both the college and society. So we like you better if you have higher observables, both of us. The distribution of test scores is weakly higher for students with better observables in the sense of monotone likelihood ratio property. And the imputed test score is weakly increasing in the observables as well. So higher observables lead to weakly higher imputed test score. This last one is going to be automatic given the first two assumptions if we have no adverse inference, but we're not really tying ourselves to any specific imputation rule. So putting this together, whether students benefit or are harmed from going test optional depends on how test scores are imputed. With flexible imputation, it matters whether you're the type of student that this college likes better than society or likes worse than society. With restricted imputation, it just matters whether you have good observables versus bad observables. Students benefit if you have good observables, regardless of the disagreement between the college and society. These might push in the same direction, they might push in opposite directions. So I think I'm basically close to out of time. So let me just wrap up. Just for the final question of when does a college benefit from going test optional, with flexible imputation, it can always benefit. With restricted imputation, it's ambiguous. We kind of just we see what happens observable by observable, and then we just sort of have to take an expectation over observables. So I won't go into it now, unless people want to stick around. I'm happy to talk about it. But there's an extended example in the paper where we talk about how a ban on affirmative action, so a ban on using some dimension of observables, think of it as like race, can push a college from wanting to be test mandatory to wanting to be test optional, or in fact, the way we model it, test optional is just the same as test blind. So preventing a college from using certain information in admissions can lead a college to say, okay, you know what? I don't want to look at tests. I used to want to look at tests, now I don't, which we think sort of captures the University of California story and also fits the prediction that many people are making about what might happen if the US Supreme Court bans affirmative action going forward. So I will end there. Yeah, happy to take any more questions.
Okay, I've just one question, not regarding the model and the calculation, but regarding the submission of test scores from applicants or from students. Have you researched if the kind or which kind of signal the submission of test scores shows the college about the student, and which kind of signal the students gets from the college, which is test blind, test optional, or test mandatory? Because my assumption is I don't believe the imputation really, the promises of the university. And it could be interesting to research after ex post the applicants which were accepted, divided in the groups test submitted, not test submitted, if there are structural differences, if there is a bias in selecting people who deliver a score independent from the score itself, who deliver a score and who don't deliver a score, just give their diploma or some awards or some references. Have you knowledge about this or some researches about structural? Yes. Okay.
I mean, the short answer is I would love data on this. Colleges are like very tight-lipped about this. You know, every so often you can get, you know, some college putting out a press release that talks about, you know, we admitted this share of, or, you know, they'll say like this share of students, you know, submitted a test score and this share did not. And of course, you know, one thing we get from that is, you know, these are not unraveling. So, you know, the simplest story would be like, you know, part of our motivation for thinking about this is like, gee, there's a voluntary submission of information. Why don't we get unraveling? In our model, it's because of this imputation story, this kind of commitment behavior. And so we kind of know that at least so far, there's not been unraveling because many students are not submitting.
Okay.
We don't really have any data on who they are. And, you know, we know that some students who don't submit test scores are getting accepted. It's not just like a ruse by the colleges for PR. But yeah, I would love data on that. I mean, the closest we get is like, you know, newspapers will like interview students trying to make this difficult decision of whether to submit or not. And you have all these fun stories about a student, you know, some of them are like super strategic. They'll like take the test 3 times and then they'll kind of get the best score they can. And then they'll like talk to their guidance counselor and pore over all of the, you know, distribution of test scores of admitted applicants at these schools. And they'll decide, okay, I will submit my test score to these schools. I won't submit my test score to those schools. You know, if people are following the rule, submit your test score when it's, you know, above the average of submitted students, you know, you just get some kind of unraveling. There's some students who are sort of very strategic, kind of looking at this, others who are presumably less strategic. You know, one kind of trope in these stories is you'll have a student who says, you know, I got a terrible test score, so therefore I was really excited that this college is test optional so that I didn't have to submit my test score, which is terrible. They never would have accepted me if I submitted, but I didn't submit. They didn't see my terrible test score, and then I got in. And it's sort of like, that's again, like part of the motivation of this is like, are they tricking the college? Like, why didn't if the college knows that people with bad test scores are choosing not to submit, then why is the college accepting them when they don't submit, but rejecting them if they had submitted? Like, why didn't the college just accept someone with a bad test score, even if they submitted it, if the college, you know, doesn't actually care about it? So that was sort of like part of the motivation for this project, is like, you know, introducing the social pressure component.
And one additional remark, of course, the ex post analysis of the applicants who are accepted is just one step. Maybe, of course, you haven't any long-term results about the factors you mentioned, like ability, holistic fit, private type. If you have a long-term longitudinal results for 10 years later, maybe the results in the short term would be overruled. And you see, oh, this was not a good, able student. We accepted, but in the long term, he was very successful or very satisfying or very beneficial for the society because it was in the politics or whatever. So the long-term data is very difficult to get. How successful is it for society? These your factors, ability, holistic fit to accept a college student or not? It's just my personal opinion.
I totally agree with that. And I mean, we very intentionally, we sort of present this kind of the model for the puzzle that has a lot of moving pieces, and then we strip them out to focus on the factor that we're interested in. So we kind of, take all of this stuff that could be endogenous as exogenous. And there's a lot of, people talking about how, if we de-emphasize standardized tests, how is that going to affect student studying behavior? Maybe students will work harder to get good grades because grades matter more. And of course, that's, all completely outside of the model.
Okay, thank you.
So could you maybe repeat what the relevant factors are to get that colleges would want to switch to test-free applications?
So with flexible imputation, it's sort of this result that, you can always do better. For the restricted imputation, it's kind of hard to say because it just depends on you have to describe some parametric environment and then take expectations over it. But the results we get for this affirmative action example, at least, are that so you have some group membership, think about this as race, where the college wants to benefit students, of a minority race, and society doesn't care about race. Society just wants to accept students based on academics. That's sort of the model we write down. And so in this model, if the college is allowed to use group membership for admissions, then our parameterization is such that the college prefers to be test mandatory. Sorry, I should have said that test scores in this example are binary, 0 or 1. And so that's kind of why test optional is the same as test blind. You either kind of see the test score or you don't. There isn't really something in between. So if we're allowed to use affirmative action and have race-aware admissions, then the college would like to see the test scores because the college cares about test scores and it can make the proper adjustment based on group membership. If the group that the college wants to benefit has higher test scores on average, then the college still wants to always look at tests, even if we ban affirmative action, because that would just make tests more important because now the test is a signal, a high test score is a signal that you're a member of the group I like. So there's a lot of discussion in the US about not just banning affirmative action, but also banning preferences for, basically preferences for rich people. Student or colleges often benefit donors or kids of donors or, legacy admits who might donate in the future. And to the extent that these are rich people who also have privileges in taking standardized tests, if having a high test score is a signal of being from the group that we want to benefit, then we definitely want to look at tests. But if having a high test score is a signal of being a member of the group that we don't want to benefit, so this would be, the case for race admissions, where underrepresented minorities have lower test scores on average. That's the world in which the college might prefer to not see test scores. And some parameters we have, the bigger the disparity in test scores is, the less the college wants to see test scores, the more social pressure there is, or the bigger a preference the college has for this disadvantaged group, all of those push the college to wanting to go test blind. Yeah, RL?
Just one remark. Maybe remember, in Germany, we have this discussion years ago. I followed in the general press about the Zentralabitur. The Zentralabitur is a from the high schools, the degree that all federal states have the same level for the high school grades, and not every country or every school can define his own Abitur or grade. And a lot of people said after implementation, the central grade tests after the high school, it's more fair. It's more fair because the personal factor and the high school factor, good high school, bad high school, social pressure. If you have a high school in a hot spot, which is not so good, then maybe they were not so good ready for the study, for the college. And this was a great discussion. What was it? 10 years ago, 15, 20 years ago, about implementing a minimum level of ability for high school students to go on university in Germany. Just simplified, explained from me.
Yeah, so one of the interesting things about the US system is that the standardized tests are the only thing that can really be compared across different high schools, because the grading is entirely decentralized. It's entirely at the school level. An A in one school doesn't necessarily have any correspondence to an A in a different school. And so when standardized tests were originally introduced in the early 1900s, the argument that was made is like, this is actually going to benefit, underrepresented students, because this is the only way that if you're coming from, a poor area where you don't have connections, getting an A doesn't mean anything at your high school, but getting a good standardized test score does mean something. And I think, whether or not this argument is less true than it was back then, I think there's sort of like, in this like discussion of, diversity, equity, inclusion, maybe the tenor of the debate has shifted against standardized tests, but there's certainly still defenders who say like, no, standardized tests are really like, every other part of the college application is either like hard to interpret or like even more based on connections and socioeconomic status than like this objective measure of how well you can do on a test that's the same for everyone. So definitely like an active debate in the US about whether even, from the diversity perspective, it makes sense to de-emphasize standardized tests.